I'm Effie Parks. Welcome to Once Upon a Gene, the podcast. This is a place I created for us to connect and share the stories of our not-so-typical lives. Raising kids who are born with rare genetic syndromes and other types of disabilities can feel pretty isolating. What I know for sure is that when we can hear the triumphs and challenges from others who get it, we can find a lot more laughter, a lot more hope, and feel a lot less alone. I believe there are some magical healing powers that can happen for all of us through sharing our stories, and I'll take all the help I can get.
Once Upon a Gene is proud to be part of Bloodstream Media. Living in a family affected by rare and chronic illness can be isolating, and sometimes the best medicine is connecting to the voices of people who share your experience. This is why Bloodstream Media produces podcasts, blogs, and other forms of content for patients, families, and clinicians impacted by rare and chronic diseases. Visit bloodstreammedia.com to learn more.
Today's episode is brought to you by Dante Labs, the global leader in genomics solutions for rare diseases. With their rare disease health package, they offer comprehensive whole genome sequencing for rare disease patients. To learn more about Dante Labs and how they're revolutionizing healthcare, visit us.dantelabs.com. Hello, friends, and welcome back to the show. This is Once Upon a Gene, and I'm your host, Effie Parks. And if you are new here, oh my gosh, I'm so glad you found us. Welcome. There is a vast library of topics and resources and stories that you can go listen to. So I encourage you to just type in some keywords in your search and find them, or message me and I'll help you find what you're looking for. Welcome to the community. I'm so glad you're here. This episode is coming out in November 2023, which is also Epilepsy Awareness Month. And I have just the raddest mom, scientist woman ever that I'm talking to, who's going to talk about Lennox-Gastaut syndrome. Today I read a beautiful post from my friend Madeline Uden. You might remember her from episode 172. She has a beautiful daughter named Margot, and today she made a post about how SCN8A affects Margot and that Margot is regressing in lots of areas because of these horrific seizures that these kids have and that they endure. And I'm just going to read a little quote that she left on it, and it says this: "At the end of the day, while we can use equipment and medications to help her eat and breathe better, there's not much else we can do to help build her strength. It's a whole new level of hard to watch your child deteriorate and need more and more support to just support her basic human body functions. There is a general lack of understanding of how much epilepsy affects all of these other organ systems, and so we all need to learn more." And I just want to put a pin in what little statement that she says that means so much about why families raise awareness for Epilepsy Month and any awareness month, whether it's for our own rare disease or one of the symptoms that our kids have, and that it's so much bigger than celebrating an awareness day, because I know that some families kind of have a little shame towards that. But I want you to know that anytime that you're speaking out and you're sharing something like what Madeline does online about how seizures are affecting these beautiful little bodies, it's important, and it's getting recognition around it, and it's getting people talking about it, because a lot of these kids are suffering. And I'm appreciative to Madeline, and I am so appreciative of my guest today, too. I cannot wait for you to meet her. She's a powerhouse, and she has an adult daughter, and she has been through so much. She says something in the podcast that I haven't forgotten, and she says, "When she seized, I studied." And, she just went on to make herself a neuroscientist to help her daughter and all other kids living with severe seizures and epilepsy and Lennox-Gastaut. So I'm really excited for you to hear this conversation, and it's definitely timely, and I think you're going to learn a lot, even if your child does not have seizures of any kind. So please enjoy my conversation with the one and only Tracy Dixon-Salazar. Hello, Tracy. Welcome to the podcast.
Hi, Effie. Thank you so much for having me. Great to be here.
Oh my gosh, I'm so excited to have you. And I know you're so busy, so I super appreciate the time that you're taking. I know that what you have to share is so valuable to so many families listening. So Tracy, can you share a little bit about your personal journey with your daughter, Savannah, and the condition that transformed you into both a scientist and an advocate?
Yeah, absolutely. My daughter, Savannah, is now 30 years old. I can't believe it. But she started having seizures out of the blue when she was 2 years old. And I was a stay-home mom. I was very, very young. And we didn't even know she was having a seizure. We thought she was choking. We were so uneducated and didn't know what was going on. And she had that first seizure, and we thought, okay, well, we don't know what this is. We got her checked out and everything was fine. And then she had a couple more, and we were completely freaked out. And then she went 6 months without having any seizures. And we thought, wow, we dodged a bullet. We didn't. The seizures came back when she was 3 years old, and we still had no idea why they started, where they came from. There was no family history. There was no head injury. She hadn't eaten lead or any poisons or anything like that. But they came back when she was 3. And from that point on, she started having seizures every day. A good day was 5 to 10 seizures. A bad day was hundreds, too many to count. And our lives were changed, they were changed after that first seizure. But once she started having daily seizures, it was really just a hell that only other caregivers who know what it's like to watch their kiddo have a seizure know what it's like. She didn't get the diagnosis of epilepsy till she had probably already had, 1,000 seizures. And it's funny because the doctors didn't want to label her with such an awful disease. So our introduction to the stigma of epilepsy was actually from the doctors who didn't want to give her actual diagnosis. And then the seizures, there's something that's really unique to seizures that happen during brain development. And there's so much brain development happening in a 3-year-old that the seizures actually take over brain development. And we don't know why this happens or how this happens. But by the time Savannah was 5 years old, her seizures had evolved into something called Lennox-Gastaut syndrome, or LGS. And I remember reading a book. There was nothing on LGS back then. This was about the internet was around back then, but I had to check out internet time at the library for an hour. So, and I remember there was a book I checked out, and there was one paragraph in this, 2,000-page book on epilepsy. And it said, the prognosis for LGS is continued seizures, progressive intellectual disability, and premature death. And it's a catastrophic epilepsy of childhood. And that was it. When we got the diagnosis, we were just devastated. And it was just so scary and frustrating, and there was no information.
Hey listeners, I want to take a moment to talk about Dante Labs and their groundbreaking rare disease health package. If you or someone you know is facing the challenges of a rare disease, this is a game changer. With their advanced whole genome sequencing, Dante Labs provides a comprehensive view of your genetic makeup, helping to pinpoint the cause of a rare disease and offering potential treatment options. Dante Labs understands the time is of the essence for rare disease patients. That's why their results are available within weeks, not months. Plus, their pre- and post-specialist consultations offer invaluable support throughout your diagnostic journey. So, if you're seeking answers and support for rare disease, turn to the experts at Dante Labs. Visit us.dantelabs.com to explore the rare disease health package and take charge of your health today.
Fast forward now, Savannah, we now know that nobody's born with LGS. Savannah didn't have it initially. It's something that developed over time. And we didn't know this back then. We thought when we got the LGS diagnosis, it's like, oh, we finally have our diagnosis now. And really, Savannah had many diagnoses. She has intractable epilepsy, right? She has a diagnosis of a bunch of different seizure types, and she has a diagnosis of Lennox-Gastaut syndrome, and now she has a diagnosis of intellectual disability. But we didn't really know that. We thought, oh, finally, we have answers to LGS, and then there was nothing. There were no answers, right? It's like with all these rare diseases. It's like, oh, here's your diagnosis, and there's no information. Have fun. So Savannah, we didn't know this, but LGS, in order to get diagnosed with LGS, you have to have a couple of things. So it's seizures that start in childhood. You have to have more than one type of seizure, which is really uncommon. This doesn't often happen. Seizures that start in adults might spread, but you often don't have more than one type, and they're constantly changing in young children. So you have to have more than one type of seizure. I think Savannah at one point had 6 different types of seizures. You have to have developmental delay. And usually that's present in LGS patients within a year of the LGS diagnosis. It's not always present right away, but then the ravenous number of seizures these kids are having causes their brain, to be under constant attack, and they start to fall behind. And then you also have to have very specific EEG patterns, and they are called slow spike and wave and generalized paroxysmal fast activity. So we abbreviate those to SSW and GPFA. And if you have those things, you have LGS. And so we got the diagnosis when she was 5. And from the time she was 5 till the time she was 18, Savannah had more than 40,000 seizures. All I could do as her mother was count them It was quite devastating. So I counted them because that's all I could do. We couldn't stop them. She tried and failed 26 different treatments, and that included diets and devices and drugs and alternative therapies, and nothing worked, and it was so frustrating because the dogma back then was so prevalent amongst the doctors. Not that it still isn't today, but we would hear things like, oh, thankfully we don't need to know what causes epilepsy in order to treat it, and seizures don't damage the brain, and you can't die from epilepsy. And then I would go home after meeting with different doctors and go, that is not true here in my house. This kid is suffering massive brain damage because she's falling behind in her development, and all of these treatments aren't working, and we're resuscitating her. So none of those things turned out to be true. And yet I still meet patients and families today that are told those things, which is really frustrating. And during that time, you know how it is, Effie, when something happens to your loved one, you just, mommy has to try to make it better, right? We got to kiss it and make it better. We got to try to fix it. Not that our kids need to be fixed, but when they're suffering, you want to end that suffering, right? And so I enrolled in college when Savannah was about 5 years old. And, we kind of laugh about it now because when I look back, was like, I don't understand these papers that I'm, getting off the internet when I check out time at the library. I have to enroll in college and take some English classes because I don't understand English. And so I took a couple of English classes and I got good grades, much to everyone's surprise because I wasn't the best student in high school, but I got good grades. And I thought, oh my gosh, these papers aren't in English. They are in medicine and science. And I don't understand them. So I started taking science classes and just fell in love with science. And it gave me something to do. Like, I can't stop my kid's seizures, but I can learn. And so I spent a lot of years going to school, and she had a lot of seizures. And so she would seize, I would study. And as you can imagine, I was a really good student. And after about 12 years, a big chunk of that remediating at the junior college, I ultimately got my PhD in neuroscience. And, I didn't go into this thinking I would help Savannah. I love it when I meet moms and dads that are like, well, we're going to cure our kid. But that was not me. I didn't have a lot of self-confidence. I certainly didn't think that anything I could do would ever, change the world. But when I finished my PhD, which was in developmental neuroscience, so how the brain puts itself together, how it develops, how it wires, I then went on to do a postdoc in neurogenetics, and I did all my work at UC San Diego, which is where we live here in San Diego. And as I was doing my postdoc is when the genomic revolution happened, right? So prior to my postdoc, which I did, oh my goodness, probably about, I think I should feel like I should know this, but I know it was somewhere around like 2010, I think, the ability to sequence all the genes, right, exome sequencing, had just become commercially available. So labs like ours, research labs like ours could take this technology and bring it in. And that was my job in the lab, was to sequence exomes. And we were sequencing the first exomes in the world, us and, the labs that had this technology. And so I remember one day my thesis advisor came up to me and said, hey, how is Savannah doing? And I burst into tears because she wasn't doing well. Back then, I think she was having about 300 seizures a month on average. That's about 75 seizures a week. She was going into nonstop seizures every week. So something called status epilepticus, where we'd have to give her at-home rescue meds, or we'd have to take her to the emergency room to stop the seizures. And if that didn't work, she would get put into these medically induced comas. And then we'd spend weeks in the hospital trying to recover from those. And she was on like 7 treatments, plus these rescue meds, plus she had a neurostimulator implanted in her body. And she was sleeping like 18 hours a day. And we were just losing her. And so my advisor, after, cursing for himself for asking, I'm sure, because no advisor every boss wants their employee to burst into tears when they ask them a question, right? But he said, we should sequence Savannah. And this was kind of unprecedented back then because we had no family history. Genetics used to mean inherited, and it doesn't mean that anymore because you can have de novo mutations, right? Genetic changes that happen after the sperm and egg come together, right? And so genetics doesn't mean inherited anymore, but just 10, 11, 12 years ago, it did mean inherited still. And so we sequenced Savannah, and it took a year of analyzing her data and a year of not finding anything. But we ultimately did find something in her after a year of just continuing to do research. And she has, all of us are walking around with 200 or 300 unique genetic variants in us. You are, I am. And some of those can be advantageous and some of those can be deleterious. And we know a lot about them in rare disease because we talk about the deleterious ones, right, in our loved ones. But Savannah's 300 rare variants that she's walking around with that are unique to her and not inherited from mom and dad fell into a specific pathway. And this is a different kind of analysis, which I still refer to as crazy mother analysis today, where you group all the genes together. You group all those rare variants together and you figure out what they're doing together. And to make a long story longer, she has a lot of genetic mutations in her calcium signaling pathway. And this really struck me because I remember, the doctors would always say, we need to put her on calcium channel. We need to put her on calcium because everyone with epilepsy is on these medicines that destroy their bones. And so we need to put her on calcium supplements. And every time we would do that, she would end up in the hospital in a medically induced coma. And so I finally told the doctors to stop telling us to put her on it. But when I saw this genetic results, I was like, no, there's something to this. And so within a few months, we had actually done a bunch of research and found there's a drug that targeted her specific mutations in the calcium signaling pathway. And we put her on that drug. It's not an epilepsy drug. It's used for high blood pressure and for arrhythmias. It's called verapamil. Everyone always asks me this. And, if you had told me treatment number 27 was going to help her, I would have just sort of done that, maniacal laugh that we caregivers do where we're like, right, sure. But damn, if it didn't work. Within 2 weeks, this kid had a 95% reduction in her seizures and 100% reduction in going into those nonstop seizures, the status epilepticus. And at 18 years old, I feel like I met my kid for the first time. And it was just mind-blowing. It was mind-blowing to me.
I mean, the places we could go. Tracy, oh my gosh. She would seize and I would study. I mean, if everything you just said from start to finish is not the most epic example of how you advocate like a mother, I don't know what is. Okay, I'm gonna kind of go a little bit in the beginning there because there's just so much information that you just shared that's so important for families. But let's talk about when they didn't want to give you labels, right? Obviously, there was super stigma back then. I feel like there still is for many of us. And it's almost just kind of like a common quip that people are told now, like, oh, don't label them. Don't label them. And maybe it's just for the human part of them, but it's also going to hurt you in insurance and school and all the things. But a label's important. And it's none of those things necessarily that are bad. So what advice would you give parents to maybe actively communicate with their medical professionals and collaborate on ensuring that their child receives the best attention and care for the seizures that the families are seeing, that they're not necessarily getting across to them?
Yeah, I mean, I think it's really important to call, a ravenous mountain lion, right? I don't think that we're doing anybody any favors in epilepsy by not calling it epilepsy, by not by calling it seizure disorder or not calling it that at all, calling them spells or episodes or events. And the reason is because I think there's a few things. One is I think it delays time to getting real help. I think it delays time to finding your tribe, or in this case, your tribes. Your loved one could have many diagnoses and you want to get them help. And in addition to that, I think it also, once you do find out what the real diagnosis is, it can ruin your trust in the medical system. And so if you have physicians that aren't giving you the information that you need, they're being very paternalistic or maternalistic, in some cases, by not giving you that because they think you can't handle it. But there's going to come a day and time where you have to handle it. And you are handling it because you're living it. You're just giving it the name that it is. And then that will allow you to get out there and really get to the help that you need. And I mean, if I did not finally, in the beginning, there was very little internet, right? So I didn't meet another family living with LGS for 3 years. It was the most lonely, awful 3 years of my life. And thank God we don't have to wait that long anymore. But your best resource for any rare disease is going to be another caregiver. And so I think just, expressing this to your doctor, it's like, hey, doctor, don't sugarcoat it. Let us know what we're dealing with here. Tell us what it is. And then you can start a real battle instead of a fake battle. There's this fake battle of, oh, it's going to maybe impact their life in the future and they'll be stigmatized. Well, they're already going to be stigmatized for these episodes or these events, right? But now you have a name and you can tackle it and you can confront it head on and say, oh no, you are not going to stigmatize my child because they have epilepsy, and I'm going to tell you why, right? Or because they have a rare disease, and I'm going to tell you why. So that's a real battle you can fight instead of this imaginary battle. And then, oh, it might impact their ability to get insurance. Well, we have laws in place right now in the US that do not allow that discrimination. And we need to keep fighting like a mother to prevent those laws from going away. But again, that's a fake battle that may or may not happen to your child and your loved ones. And the real battle is, getting help with the stuff that you're dealing with. And I mean, I don't think there's any doctor out there that does it on purpose. They are really trying to help, but I think they're getting their help all over us, and they need to stop it and just give it to us straight and let us deal with it so we can manage the situation and get to the best possible care first. And I think you just have to straight up say that to the doctors. Otherwise, they are going to treat you with kid gloves if that's their chosen way of treating people.
Yes. Oh my gosh. I mean, we're in a new era, right? Like patient advocates, caregivers, and patients have the ability to absorb and understand and take action on enormous amounts of information and learn the science and know what we need day to day. And there absolutely is such a beautiful movement that hopefully happens stronger and faster, that we are experts at this table and we don't need to have kid gloves because we're literally making it happen.
I 100% agree.
Yeah. And that find your people thing, I mean, I think that's the soundtrack of Once Upon a Gene for sure, because finding your people is what is going to, take you out of that horrific isolation piece. And it's going to be a great sense of support, and you're going to make relationships and build connections and be inspired to take action in some way. And so it's so vital that that's your first step, in my opinion.
I agree. I love it. I love that you're out here, Effie. I love that Once Upon a Gene is out here helping families to try to find their tribes.
Thank you. The amount of expertise and data and just like phenomenal energy in our communities are they're just so powerful. You made me think of something earlier. You said that the medical professionals said, well, thankfully, we don't need to know the cause. And, clearly you were repurposing drugs before drug repurposing was cool. And so maybe I wonder if you could maybe dig in a little deeper about these umbrellas, because I'll name some of the big ones, like you did: epilepsy, autism, cerebral palsy. And I see this especially in the epilepsy and cerebral palsy groups that I follow, that these families really don't understand the definitions of those. And quite frankly, I don't think they're being told the correct definitions either, because they seem to change often. But what would you say to a family who has this umbrella term, who hasn't had genetic testing, and how important it is, especially since you can figure out how to get a precision medicine like you did and saw your daughter Savannah for the first time?
Yeah, I mean, I think it's critical. If you have unexplained neurological condition, or even just an unexplained disorder that started in childhood. And I think even now, the science is starting to really look into adulthood as well. So I don't even think I'd limit it, but you have got to get genetic and genomic testing. And let me just give you an example within the context of Lennox-Gastaut syndrome. So Lennox-Gastaut is always umbrella under the epilepsies, even though one of the main features of it is intellectual disability. And half of the people who have LGS have a gene that started their seizures, right? And so this gene could be tuberous sclerosis gene, right? TSC1, TSC2. It could be Downs, so trisomy 21, and I'll just name some others: SCN1A, SCN2A, DUB15Q, any early life onset seizures that are caused by a gene predisposes you to LGS. And sometimes we think about LGS as metastasis, not scientifically, but like it, sort of as a metaphor, right? An analogy, right? Like the seizures spread to take over brain development. And so we have no idea what causes LGS, but we know a ton about what causes early life seizures. But there's over 700 genes that predispose to LGS. The other half of the people who have LGS have an acquired insult, right? So lack of oxygen at birth, hypoxic ischemia, for example, is a big one. We have kids who got cancer when they were young and they went on chemo, and the chemo caused seizures, and then they evolved into LGS, right? And so we always say, if you do not have an acquired form of epilepsy, you have to go in and get genetic testing. And this is so important because, especially if you are not responding to the currently available medications. We have more than 40 treatments for seizures that exist today, and none of them are targeted towards the unique biology of my child, right? They test them. There's a group of scientists that get funded by the NIH. It's called the Epilepsy Therapy Screening Program. And they have like 7 or 8 models of seizures. And they try different drugs in these 7 or 8 models. And if they pass that screening, then they get considered, an anti-seizure medication, and then they might get brought to clinical trials. But some of these, it's like one of the models is where they inject a syringe full of something that's a little bit like Agent Orange into the ventricle of the animal. Right. And I'm like, I've just never met anybody who's fallen on a ventricle of Agent Orange and gotten epilepsy. And so, it's not really paralleling necessarily what's happening in humans. And in addition to that, they've all been made this way, every single one of the drugs that we test. And so we literally keep hitting the nail with the same exact hammer, thinking we're going to get different results. And maybe my kid doesn't need a nail. Maybe my kid doesn't need a hammer. Maybe my kid needs a screw. Maybe my kid needs, some other shape that we're not thinking of. And that's where genetics comes in. So, if Effie can't convince you to get genomic testing, whole exome is becoming much more affordable and is a great way to start. If you can get whole genome sequencing, do that, but that is much harder to get covered. And even panel testing, there's nothing to balk at. So if they say we're going to do a cerebral palsy panel, or we're going to do an epilepsy panel or an autism panel, do that, because even if there is no currently available treatment, I want to say there's about 25 genes right now of the, several hundred epilepsy genes that are out there. There's about 25 that have a potential targeted medical action. It might not be go on this treatment, but it might be, hey, you should really watch the growth of this child because they're really prone to ataxia. And so while they're young, put them into really extensive physical therapy, right? And OT, PT, that kind of thing, right? So some of it's that, some of it's, don't go on these medicines. But even though it's only 25 genes out of 700, this is the future of medicine. And there are repurposing efforts, and biology is becoming much more precise, and treatment of patients is becoming much more precise to the individual. So this is the future. So even if there isn't a treatment, you can help pioneer and bring in a new one. And this is especially true in rare disease, where we don't seem to respond to the stuff that's out there now, right? I mean, do you really have to, try and fail 26 different treatments before you get to the right one? I hope that's not going to be the future. And in addition to that, LGS is so interesting because the way intractable epilepsy is just treated this way. And what our families actually call the dartboard approach to treatment. One dart is one medicine. And so, or one treatment, it could be a brain surgery, it could be, a neurostimulator, it could be a diet, it could be a medication or an alternative therapy. And we throw one dart in patient A, and we throw a different dart in patient B, and we throw a different dart in patient C, and they all end up on multiple combinations. Most of them are on 3 to 4 drugs or 3 to 4 treatments, and we don't write anything down. We don't study them. And so, LGS was described in the 1950s, and we've been treating it with the dartboard approach since that time. And so I think genomics and genetics is going to change that. And I think that there's also other ways that we can sort of focus on the science of LGS in a different way. But I think this is going to change everything. So do not pass go. Do not collect $200. Go out right now if your loved one has an unexplained rare disease and push to get genetic testing. Start with your doctor. If that doesn't work, you can also contact the companies. If you have a child who's under 8, there's free behind the seizure. Is free genetic testing for anybody who has seizures under the age of 8 years old. So there's a lot of different things out there, and I'm sure Effie and I can help you to find a place that will help you get sequencing for your loved one.
I mean, Tracy, did we mind meld? I say the do not collect $200 thing at least once a day, okay?
We're sharing in one brain.
I think you're a lot more graceful in the genetic testing world. I do balk at panels. I think that families should be able to get their whole exome sequencing if that's the panel that they want, but I hear what you're saying. And yes, anything is important.
I'm with you. I think everyone should get a whole genome. And here's the thing that really kills me, Effie, is I think every discipline needs a whole genome, right? And so why isn't my neurologist and the GI doctor and, the people who are working with Savannah on her development, right? Like her developmental issues, like why aren't they all using the whole genome, right? And then she's on psych meds and sleep meds, right? So all these doctors should be able to use the whole genome. But I also realize we live in this real world, and I don't want people to wait. Sometimes you have to fail a panel in order to advance to whole exome. And so I think everybody should be getting whole genome at birth. the reality of the situation is we're going to have to fight for that. And right now, if a panel is all you can get, start there and then keep pushing for the whole exome and the whole genome. But I'm with you, but I also make some allowances for the real world because we work with enough families that have been denied and then just have to, all right, you failed the panel. Now you can ask for the exome, right? And you don't really fail the panel. It's just like, oh, you do not have mutations in these, 700 genes, right?
Yeah, I love that idea. My mind was just blown a little bit when you were like, why isn't every specialty necessarily analyzing it for their patients? That makes such amazing sense. And maybe that's where AI can come in eventually and help this load of when all of this data is going to be generated more commonly. That's so cool to think about because, yeah, I mean, you would actually get the help that you need quicker and more direct for sure. And yeah, I think about my friends and all of their kids who are on, 4 or 5 epilepsy drugs just because they're on them and their kids are obviously not necessarily completely improving. But what advancements in treatment or management of these seizures have you found most promising other than just putting all of these kids on seizure drugs? What have you found that's most promising like in the last couple of years?
Anti-seizure drugs have their place, but there's data that shows that if you don't respond to the first, second, or third seizure treatment, your chances of responding are less than 1%, right? So I don't understand why we are continuing to try drug after drug after drug after drug. And then one of the things we never talk about, but if you get the best doctors, they will tell you this, and they'll say, we never talk about how the seizure meds make things worse and how they are disrupting the developing brain or even the adult brain, right? And how they might actually be contributing to the problem. And so I think we need to get absolutely more precise with the drugs we have. Right now, it's just really lucrative to make anti-seizure medicine, so we just keep making more. But we have to push as patients and say, we really want you to stop experimenting on us, and we want to know what's going to be the best one for me, based on my genetics. And, one thing we don't talk about as well, which is so many things we don't talk about, but is pharmacogenomics. We actually know a lot about how these drugs work in relationship to your genetics and your genomics. And that is never used in making decisions about which drugs our loved one's going to go on. So I think pushing that is important. I do think there are a lot of people who are waiting for the next treatment to come out. So developing new anti-seizure medicines is not anything to, stop doing. So we need options. There's people who do need options, but we have to get a bit smarter about how we treat people, especially the young kids. And then I think what excites me the most is thinking about treating the network. Okay, so no one's born with LGS. So let's take the case of a tuberous sclerosis, because this is where we have the most scientific data. These patients, these babies are almost often identified in the womb as having tubers in their lungs, in their hearts, in their brains, in their kidneys. So the minute they're born, they will get tested for TSC1, TSC2 mutations, for tuberous sclerosis genes. And so they know, and they can even be tested in the womb now, right? They know. And we also know that 80% of those who have TS, those babies, will develop seizures in the first year of life. Okay, so I believe there's interventions at a lot of points. So let's go to the very beginning. If you know TSC runs in your family, one of the things you can do, is to think about pre-implantation testing, right? We can get rid of familial forms of disease with pre-implantation testing and testing the embryo before it's implanted. Now, not every woman is going to get pregnant that way or wants to get, and you have to go through IVF, which is very hard on ladies, but you can do it. So if you want to intervene there, great. If you want to intervene at the very beginning, okay, you were born with TSC, we're going to put you on a drug that to try to prevent you from developing seizures because we know you have an 80% chance. For the love of God, do that. And don't just do an anti-seizure med, do a targeted treatment towards TSC, towards the mTOR pathway. There are treatments that are out there. And then, okay, let's say they don't stop your seizures and you do develop seizures. Okay, now it's time for you to go on an anti-seizure med. And if be really smart about the ones we need for these TSC kids, which ones work best, let's study it. And then after they failed the third medicine, now we need to start thinking about preventing them from evolving into Lennox-Gastaut syndrome. And you'll hear the doctor say, oh, their EEG looks like it's going LGS. Let's quantify that and target treatments against that. And then I think you can also, treat the EEG. If you say this to an epilepsy doctor, their brain explodes. You actually say this to your doctor. If they don't treat the EEG, because there's so few that do this, and watch their brain explode, you'll see it. Just watch your face. But I don't understand why we don't treat the EEG, because the EEG, when they look like they're evolving into LGS, is the big bad. And when you have LGS, the EEG features are the things that the EEG is in LGS shows the brain damage. It is a sign that the brain has put itself together wrong. And so why aren't we treating that in LGS? And so these are the things that excite me, and I think in the last 10 years, there's this incredible research that shows that no matter how you developed LGS, so no matter what your etiology was, right, what caused it, your seizures, no matter what your age is, no matter what your gender is, the slow spike and wave that they see on the EEG and the GPFA come from the exact same brain regions in every single person. So, and when you map it down, it's like the brain has wired itself wrong in the same exact way. And it's almost like, it's a good analogy would be like, no matter how you get a cut on your arm, it always bleeds, right? Bleeding is sort of the universal thing that happens when you cut your arm, right? And for some reason in LGS, they all evolve to the same abnormality. And so why aren't we targeting that? And so I think when I think about treatments, I think about how do we get the right treatment to the right patient? And a lot of this is going to come from your own unique genetics at the right time, every time. And I think that it's really going to be the patient movement, and it is the patient movement, the rare disease movement especially, that is demanding the research that is going to be needed in order for that to become a reality. Because otherwise, you would just have doctors saying, and I love to give doctors a hard time, I am also a doctor, but the system would just be saying, well, let's just keep doing it the way that we're doing it. Because again, like I said, it's like, until there was an LGS foundation, we've just been treating LGS the same way for since the 1950s, and it hasn't really changed. And so the system has had its chance. And now patients are the secret sauce that are coming in and saying, let's stop doing it the exact same way. Let's get smart about it. Let's be innovative. Let's try something new. Let's think about genetic targeting. Let's think about evolutionary targeting. Let's think about targeting the network. And let's think about what treatments are going to be the best for each patient. Whereas the system is like, let's just keep making more drugs and let's keep doing things the same way, but expecting different results. And it doesn't really impact me that much because I'm going to be able to get my grants and my papers and my promotions and have a great career. But we as patients don't have that luxury. I mean, I'm all for grants and papers and careers. I'm totally down with that. But when it's your kid and you're suffering and you're writing, marking down seizure number 40,000, your incentives are a little bit different and you're willing to try crazy things like putting your kid on a blood pressure medicine, right? And doing crazy mother analysis with genetics. And so I think patients are the secret sauce. The caregivers are the secret sauce to shaking the system up and making it really serve us instead of using us as subjects that are experimented on, which is the old way. But there's a new way now. And we want to help.
Tracy said what she said, okay? Oh my goodness. I wonder if you can quickly maybe summarize that key statement that the families need to approach their doctors with about that EEG that you mentioned a moment ago. What is that advocacy statement that they need to go in with?
Right. I think when it comes to the EEG, I think going in and just saying, listen, I have a kiddo and they're having seizures. Is it LGS? Do they have the brainwaves seen in LGS? Yes or no? Okay. If they don't, do they look like they might be going LGS? Do they look like they could develop LGS? Are they at risk? Right? And the doctor will say yes or no. If the doctor says, I don't know, then you should find somebody that knows how to read the EEG a little better, right? Because this is all stuff that can be determined, right? And if they say no, great. But if your child, I feel like you get a risk score for LGS, right? If you have more than one seizure type, seizures that started in childhood, seizures that are uncontrolled, you've tried and failed more than 3 different medications, you had previous infantile spasms and developmental delay is present, and the EEG is abnormal, it's like you now have 8 points suggesting you're on your way to LGS. And you don't want LGS because LGS is the brain has wired itself wrong, right? And once you have it, the brain has wired itself to seize is how we kind of explain it to other families. And so children with LGS have a lot more seizures than children who don't have LGS. And so you want to be aggressive, you want to target it. And so just asking your doctor about the EEG and saying, where are we? We don't want LGS. We want to stop these. And how can we do it? And so I think sometimes we're a little gun shy in the beginning and it's like, oh, well, let's just take it slow. Let's watch and wait. It's like, well, we don't want to wait because time is brain. As your child is seizing and as they're having more and more seizures, the more seizures they are going to have. And so we've got to stop them early. And if you don't have a doctor that's doing that for you, then it'd be really important for you to find one. There are level 4 epilepsy centers that have pediatric and adult epilepsy specialists, and they're not without their issues, but they know how to read EEG.
Yeah, nobody wants LGS. I wonder, because I think I I think I've seen some families get that diagnosis who maybe perhaps doesn't necessarily hit all the marks to have LGS. So I wonder, does it help or does it hurt a family advocacy-wise or in terms of care to get that diagnosis? Does that make sense?
Yeah, that makes perfect sense. So as a scientist, Tracy's going to have her science hat and her mom hat. So as a scientist, if we want to learn how to target the EEG and LGS, we need to do studies on people that have all the features I listed. It's 4 things, right? Seizure onset in childhood, more than one seizure type, specific brain wave patterns that you see on the EEG test, and developmental delay or intellectual disability. 4 things. It's a syndrome, right? It's a group of symptoms. However, in the real world, so again, this is going back to the real world. This is kind of like the panel conversation we just had. In the real world, having the LGS diagnosis gets you access to things. And so if you don't have all 4 of those features, but you're close, you're LGS-like, right? So maybe you have 3 of the 4. Doctors will often give you the diagnosis in order to get access to treatment. And I have no problem with this, right? Because if you can't get access to drugs like cannabidiol or fenfluramine, just because you don't have the LGS diagnosis, that seems a shame to me, because those drugs were not targeted against LGS, they were targeted against seizures. And it was a financial reason for why they were done in clinical trials in LGS, right? LGS is an orphan disease and there were orphan incentives. It was a business decision, and that shouldn't prevent your kid from getting access. In addition to that, if you're living with a lot of seizures, you are always welcome in the LGS community, whether you are LGS or LGS-like. And you will find a lot of families that know how to keep their kids safe on the toilet when they drop and have a seizure, right? And so I do think it helps in the real world. But when you do a scientific research study, you do want to have the very specific diagnosis. But in the real world, it's really about access and how are you going to get everything you need to take care of this really complex kiddo. This happened to Savannah too. This is not a new thing. So Savannah does not have autism or autistic features, really. She's the most social person I know. She doesn't really have stereotyped behaviors. She's not a social. She doesn't have sensitivities like that. But they wanted to label her with autism, 25 years ago, because it would get her access to services. And I was like, but she doesn't have autism. And she doesn't have cerebral palsy either. But those would have given her access in a world where there were no services for epilepsy or LGS. And so I told them not to give them to her, and she suffered. She didn't get as much physical therapy. She didn't get as much occupational therapy. She didn't get access to the services that CP kids, and autistic kids were getting 25 years ago, because I was trying to stand on some moral high ground about her diagnosis. And, looking back, I wonder if I think I would rethink it, because that would have just been help for me. Like, right. You need to know what your kid is having. You need to know if you're autistic. So in the LGS community, we don't, a lot of our kids get the diagnosis of autistic features. They don't get the diagnosis of autism. So I'm not saying give the wrong diagnosis. Right. But I'm saying you can say somebody's LGS-like, you can say somebody has CP-like features, and your main diagnosis is whatever your main diagnosis is, but those things might help you navigate a world. And so, yes, I realize this is very controversial, but you know what? The people who want to argue with me have not spent the last 27 years raising a kid like Savannah with all the seizures she's had and all the issues she's had and all the fights I've had with insurance companies and schools. So they can come, bring it on. I'll fight with you.
That's right. That's right, baby. I just think of it as like, I had a visual in my head of all of us families kind of just being like bag ladies, right? And just collecting as much as possible of anything we could to help our kids.
Right.
Yes. Oh my gosh, I love that. Are there any promising areas of research that you're funding at the LGS org that you believe could change the landscape of the treatment in the coming years?
Yeah, we're so excited. So we helped to fund the first ever mouse model of Lennox-Gastaut syndrome, which it replicates the brainwaves. And this is a little mind-blowing, because there's 7 FDA-approved drugs for LGS, none of which have been targeted towards the EEG, right? It's all been targeted towards seizures. And like I said, it's a business decision as to why those were tested in LGS as opposed to a scientific reason. They're anti-seizure medicines, right? They're not LGS medicines, right? And even their FDA approval is seizures associated with LGS. So we are now targeting in an animal model of, that replicates the brainwaves of LGS, something called focused ultrasound, which is a non-invasive therapy, to see if we can prevent the evolution to those abnormal brainwaves. So I am so excited about that. In addition, we're funding some research to quantify, when I mentioned it looks like kids are going LGS, and they usually go LGS. They usually develop LGS before they're 5 years old. In the majority of cases, not exclusively, but in the majority of cases, they develop LGS before age 5. And so we're quantifying that EEG. What does that look like? If a doctor can pick up a pattern why aren't we quantifying that? Why aren't we targeting it, right? And so we're doing that. And then we also just launched our Learn from Every Patient database, which is essentially a natural history study. So we can actually start learning from this dartboard approach to treating LGS. What works, what's the best, what doesn't. And we're capturing information on, what is your etiology? Like, was it genetic? Was it acquired? And then thinking about, okay, well, which treatment might be better? There's a study going on right now by a group at Lurie Children's who are looking at seizures versus surgery versus medication in LGS, right? So they're looking at surgery track patients versus medication track patients. And then at the end of 4 years, they're going to see who did better. And it's a prospective comparative effectiveness study. So I'm really excited about that. But, I still meet more people today that say, oh, LGS is just so hard. We don't like to give that diagnosis. There's nothing we can do. And I say there is something we can do. And so this is the kind of research that gets me really excited. So I'm excited. I hope, 10 years from now that every patient is treated having looked at this Learn from Every Patient database, right? Where something has been gleaned. Oh, we noticed that tuberous sclerosis kids respond best to this seizure medicine, right? Or this drug combination, this cocktail in LGS is the best one by far for most patients. Or these seizure types respond to this, right? And I hope that we are doing trials to target the EEG and not just the symptom of seizures, which is a single symptom in LGS, because there are so many other issues that manifest.
I wish I had an AM radio that just constantly I could tune to that had you just going on and on about this stuff. You're such a badass, Tracy, and I'm so grateful for you. Thank you for becoming a rare mom scientist. I'm so glad that Savannah has you and that the rest of the world does too. I'm so happy that she's 30. Also, I can't believe it because you look 30. It's sort of weird. I won't ask you about your teenage history there, but that's so cool. I'm so excited for this community. And I wonder, in terms of advocacy, what are some of the most effective ways for parents and caregivers to contribute to advancing some of this research and awareness for LGS?
First and foremost, we're here to support you. So if you're living with anything that looks like LGS, a lot of seizures, please come join our community. You're more than welcome. We have an online Facebook group. We also have an online private community that's not on Facebook if you're not really a Facebook person. But check us out at lgsfoundation.org. And then for rare disease in general, I think it's up to us to not let people discriminate against our loved ones and to say, rare disease is common. It affects 1 in 10 people. And to keep continuing to raise that awareness. If you can get involved in research, if you have the wherewithal to do that, do it. But before you can do that, you got to fill your own cup. So you got to take care of yourself. You got to make sure your loved one is in a good place. And I don't think you should feel guilty about that. If you're navigating the space, and you can't always participate in every research study or everything, but get with your group. If your kid has LGS and you want to be in the LGS research study, great. If your kid has a specific genetic change, like a CACNA1A is a calcium channel, my kid has a mutation in that, and there's a specific study there, your loved one's data can really change the journey for the next kids that come down the pike. And so I think that that's huge. And so the more we're out there talking about it, don't be afraid to talk about it, the more we're out there helping advance research with our loved ones, and the more that we're, shooting down sort of these fake problems and addressing the real problems, right? A lot of people say, LGS is just so rare. I'm like, well, rare disease isn't rare. And, so the approaches in LGS can impact others. I think the more we can kind of shoot those things down, or say patients, want to be hidden behind the HIPAA laws and be protected. And you say, well, no, actually rare disease patients are very sharing and want to give. But let's just start confronting some of these dogmatic ways of thinking and do it in your everyday life with your loved one. Make sure they're getting the best care. And then if you can do it on a bigger scale, there's certainly no shortage of work to do.
Love that so much. Maybe some of the stuff you just said would go into this, but maybe not. It's November when this episode comes out, which is Epilepsy Awareness Month. And I wonder if you can talk to those families who are so afraid, who are living with severe epilepsy and LGS syndrome, and maybe give them a little bit of your sparkle and let them know that you're seeing them, and maybe a little piece of your wisdom 30 years in.
Yeah. So epilepsy is a tough one, right? Epilepsy, it's terrifying to watch anyone have a seizure. And it's heartbreaking to watch somebody that you love, like your child, just to have the seizure and to suffer and to be so helpless and so powerless. One of the things that is most vivid to me is that the future that I imagined for Savannah and all the fear I had and all of the things I thought were going to happen. Oh my gosh. And even that paragraph that I read, continued seizures, progressive intellectual disability, premature death, right? All of the fear that caused me. Her life has been so much better than what I dreamt up in my head based on fear. And thinking about the future and being afraid of it and being worried doesn't give you the joyful moments. It doesn't share with you all the little joys that you're going to experience and the unique, beautiful things about your loved one that you're going to see in the day in and day out. Savannah's just such a beautiful soul, and she cares about everybody. And it's just amazing to see all the things we learn from her. And so when you're visiting the future, maybe just remember that whatever you're going to imagine is probably going to be worse than it's really going to be. And maybe just live in the now. Enjoy the now. Tomorrow is really promised to none of us, whether we have epilepsy or not. And then just know you're not alone. All of us at the LGS Foundation, we represent an 11,000 member community. We are here for you. And there is a whole group of people that are fighting to make things better and to try to help stop seizures and epilepsy. So you're not alone. You got this. And, just the sheer fact that everything that you've overcome today has prepared you for this moment. You're going to overcome this next moment. And so it's Epilepsy Awareness Month. Get out there and let people know what it is if you're comfortable doing that. But mostly just know you're not alone, and find your tribe, and we'll lift you up on the days where you just can't get out of bed.
Oh my gosh. Such powerful advice that every single one of us can take in. Thank you so much, Tracy. I really appreciate you being on the show. And I know so many families are so lucky to hear this episode, and they can find you. I'll include all your links in the show notes if anyone has any questions. But thank you so much for sharing this little bit of your story with us. I don't know how you do every single thing that you're doing. You're so smart. Tracy, I love you so much. Thank you for being my guest.
Oh, thank you, Effie, for having me. It's really great to be here. Keep kicking butt on Once Upon a Gene. It's a great podcast.
Oh. A special thank you to Dante Labs for sponsoring this episode of Once Upon a Gene. To learn more about Dante Labs and how they're revolutionizing healthcare, please visit us.dantelabs.com. I hope you've been enjoying this podcast. If you like what you hear, please share this show with your people, and please make sure to rate and review it on iTunes or wherever you get your podcasts. You can also head over to Instagram, Facebook, and Twitter to connect with me and stay updated on the show. If you're interested in sharing your story, or if you have anything you would like to contribute, please submit it to my website at effieparks.com. Thank you so much for listening to the show and for supporting me along the way. I appreciate y'all so much. I don't know what kind of day you're having, but if you need a little pick-me-up, Ford's got you.